Welcome to video 1 of the calculus summer assignment. We're going to get right into it, looking first at the idea of simplifying expressions. Again, most of these concepts are not new concepts. It's just a matter of getting us back into the swing of things and just looking at a couple of things that are very common in some of the calc curriculum. So what you're going to see a lot are fractions, and we've done a lot of these rational expressions. When I want you to simplify it, anytime you see a fraction, you should be thinking try to factor both the top and the bottom. So I have this fraction, I should probably be able to factor it. Factor the 7 subtracting the 6 are going to be 7 and 1. So we're going to have a plus 7 and a minus 1. And on the bottom, I'm going to be able to factor out an x because they both have an x in common, and I'll leave you with an x plus 7 left behind. And what I should see is I have a factor of x plus 7 that is the same. So I can eliminate those and be left with x minus 1 over x, and that would be your simplified answer. Main thing here, remember you cannot cancel that out. That is an absolute no-no. Now something else you could do, I call these kind of the heart problems. If I have just one term in the bottom, I can take each part individually and simplify it. So that would be x over x would become a 1, and 1 over x is just, well, 1 over x. So I could have something like that as an answer as well. So either way, whether you prefer this x minus 1 over x, that's cool with me, or this 1 minus 1 over x could also be useful in some situations. All right, number 2. Problems like this are very similar in the first, are very familiar, I should say, very common in the first couple weeks of calculus. Let's just try to simplify this, get rid of all the, excuse me, all the exponents and parentheses. So first, x plus h squared. That does not mean x squared plus h squared. No, we need to FOIL this, x plus h the quantity squared. So that'll become, keep the 3 in front, this will become x squared plus xh plus another xh, so plus 2xh, plus h squared. Okay, minus 4, I'm going to keep everything else the exact same up top, still all divided by h. What you're going to notice when we do some of these problems is we're going to eventually need to get rid of an h. We'll talk about this. This deals a lot with limits down the road, so you'll see how this is going to kind of work out here. So let's distribute this 3 through here and this negative through into the second set of parentheses to get rid of them. So it'll be 3x squared plus 6xh plus 3h squared. I have a minus 4. Let's distribute this negative through, so it'll be a minus 3x squared and now a plus 4. Again, all over h. What you're going to realize in these type of problems, you're going to find things that are canceling out. You have a plus 3x squared and a minus 3x squared. You have a plus 4 and a minus 4. They all cancel out. So what I have left now would be 3xh plus 3h squared. Is that correct? Yes. All over h. And now what should be left, excuse me, or wait, I'm sorry, it should have been 6xh. My apologies. 6xh plus 3h squared. All over h. And again, kind of like we did up here with the idea of the heart, I can take each of these and kind of divide them out individually, or look at that. I have an h everywhere in every single term, both top and bottom. That means I can get rid of an h everywhere, both on the top and the bottom. So that leaves me with 6x plus 3h. And that is your fully simplified answer. All right, let's look at another problem very similar to that. First off, x plus h cubed. Okay, this means x plus h times x plus h times x plus h. Well, we already did what one set is. That'd be x squared plus 2xh plus h squared. I have to multiply that by another x plus h. Okay, when you FOIL that out, you would have to multiply the x squared by both x and h, the 2xh by x and h squared by x and h. You can check and confirm with me, but this should be x cubed plus 3x squared h plus 3xh squared plus h to the cubed. It's possible you could be given problems like these with x to the 4th or x to the 5th. I wouldn't do that to you, but it is very possible for that to pop up. So we're going to take this, write it out. So I have x cubed plus 3x squared h plus 3xh squared plus h cubed. That was simplifying this part. Let's distribute the 4 through, giving you a 4x and a 4h. Okay, and I'll distribute this negative through. So it would be a negative x cubed and a negative 4x. So I almost ran out of room. All divided by h. Okay, same idea. Let's see if things will cancel out. Well, I have a plus x cubed and a minus x cubed, a plus 4x and a minus 4x. So everything else is what's going to be left behind. So I'll have 3x squared h plus 3xh squared plus h cubed plus 4h all divided by this h. So that h there I can then cancel out if there's an h everywhere, which there is. So I can get rid of one h everywhere. So that'll become h squared, that'll become just h, and that h will go away. So that means my final answer here will be 3x squared. This part will leave me with a 3xh, and this part will be an h squared, and this part will be a 4. So that there will be your final answer. And also, while I'm thinking about it, start getting into the habit of boxing all of your final answers. It's very, very key when it comes to AP testing. All right, and number 4 here, what we're going to look at with this one. Excuse me. We're going to kind of first start by getting into the idea of the rational exponents. We talked about this briefly in trig. If I have a cubed root, I don't like things under a rational, so I'm going to try to simplify it if I can. What I mean by that is I'm going to write it as x to some power. So instead of the cubed root of x, remember we always said the fraction was the power over a root. So we're saying right here this is x to the first power and to the third root. So I can always rewrite it as x to the 1/3 power for that cubed root. If it was the squared root of x, for example, that would be x to the 1/2. If I had x to the 5th and then to the 7th root, that would be x to the 5/7 power. That sort of idea. Okay, so let's rewrite this. I'm going to keep the first guy the same, 2x cubed, minus this x to the 1/3. I'm going to keep plus 8x. Okay, now on the bottom, I have the cubed root of 8x. That should be the whole thing, cubed root of 8x. Okay, that means I can take the cubed root of each part. So let's first take the cubed root of 8. The cubed root of 8 is just 2. And the cubed root of x, well, it's the same as what we did up here. It would be like x to the 1/3 power. Okay, now to simplify this, again, I only have one term on the bottom. So that means I can divide every single thing in the top by the bottom. So I'm going to divide the numbers by themselves. So 2 divided by 2 will become just 1. Now, x cubed divided by x to the 1/3. When I divide when I divide variables, what I do to the exponents is I subtract them. So like if it was x cubed over x, it'd be like 3x is up top, 1 on the bottom, 1 set would cancel out. So that means 3 minus 2, or 1 would give me 2. Same here, 3 minus 1/3 would give me 2 2/3. Start getting used to the improper fractions, 8/3. So x to the 8/3 power for that first guy. Okay, same here. First divide the numbers. 1 divided by 2 is 1/2. 1/3 minus 1/3 is just nothing. So that part just becomes 1/2. The last part here. 8 divided by 2 for the numbers will give you 4. X divided by x to the 1/3. So x to the first minus 1/3 would give me x to the 2/3 power. Okay, we're going to do a lot of work with these fractions, but the main thing to think about is mainly here changing these radicals from a cubed root or a squared root into these fractional rational exponents. All right, one last one to try to simplify, and this one will be I won't say the most complicated, but just maybe the most cumbersome to do. So, one step at a time. If I have a fraction squared, I just need to distribute the squared into the fraction. So this becomes x squared over 16. This part is still 1 over x, and I'll simplify the bottom as well. Bring in the cubed to everything. So 1 cubed is still just 1. The bottom here, 2x, that whole thing cubed, would now become 8x cubed. Okay, I got multiple fractions going on here. So this fraction up top, this big fraction, I need to make into one fraction. So I need to find a common denominator. So I'll just multiply this guy by x over x, and this guy by 16 over 16. That means that this will now be x cubed plus 16 all over 16x. And then this denominator is the same, 1 over 8x cubed. Now, how do we divide fractions? Well, like we've done many times, we're going to flip and multiply. So I'm going to rewrite this instead of dividing by 1 over 8x cubed, multiplied by the flip of that, the reciprocal, 8x cubed over 1. Okay, and now I can just try to simplify it if I can. What I'm going to notice here is that I have just one term in these diagonals. That means I can be able to cancel anything I can. Well, 8 divided by 16 will become just 1/2, so I'll get a 2 on the bottom there. And I have an x cubed here, 3x's up top, only 1 on the bottom. So 1 goes away here, and 1 goes away there to become x squared. So that means, up top, I now have x cubed plus 16 times this guy left is x squared, and all I have left on the bottom is a 2. I could leave it like that, or I could distribute this through, which would give me x to the 5th plus 16x squared all over 2 would be a fine, perfect, good solution for you. Alright, so mainly what I'm looking at here in this lesson is making sure you understand the idea of these fractional exponents, and then all this stuff with the h, mainly looking at, you're going to see very commonly things like this end up canceling out so you can get rid of an h on the bottom. We'll be seeing a lot of these come fall.